day, everyone. I am Ramos.
I am Jandoc.
And I am Maestro, and we will be discussing about polymer casting.
Casting is a common manufacturing process in which a liquefied material is poured into a mold cavity that takes the geometrical shape and size of the finished part. The material is then allowed to cool until it hardens into the desired form. The final product is then removed from the mold and is subjected to finishing. The process does not need any internal reinforcements for a material to take the shape of the mold. All it needs is to simply solidify. When we are asked what casting is, we instantly think that metals are the only material involved in this process, since it is the most common process depicted in movies. However, there are different types of materials that can be casted, and one of those is polymer. Polymer casting, as its name suggests, is a casting process that uses polymers to create finished products. In comparison to molding and extrusion, polymer casting does not rely on a significant force to push the liquefied material to take the form of the mold cavity. Atmospheric pressure is enough to fill the mold. This process is popular among hobbyists for leisure purposes, such as creating collectibles. Plastic casting process involves the following basic steps. First is pattern making. Before creating a casting mold, a physical model must be designed first. Computer-aided software is used to design the dimensions and geometry of the model, which then will be used as a pattern. Afterwards, aggregate materials such as sand, concrete, or plastic are packed around the pattern. Next, we have core making. Cores are solid materials placed into the mold to create internal features such as holes, internal passages, or hollow cavities. The next step is molding. The material to be used to create a mold depends on whether it is an expendable or non-expendable casting. In expendable casting, sand, wax, or rubber is used, while metals are used in non-expendable casting. In this step, the material of choice is poured over the model and is allowed to solidify. Afterwards, the solidified material is then removed, and the casting process may now begin. Next is melting and pouring. In this step, it is important that any solid material must be melted first. Then, the melted plastic material or solution is poured into the mold cavity and is left to cool and solidify. The important thing in this step is to make sure that the material is melted properly. The last step is finishing. There are instances that the liquefied material fills in the cracks present in the pouring channel of the mold. To solve this, finishing techniques such as sanding, grinding, and buffing are applied to the casted parts. After achieving the desired look and surface texture, additional post-process such as painting may be required, depending on the specific applications of the final product.
Now, we will justify why or why not to choose casting as a manufacturing process. First, what are the advantages of casting? Polymer casting is a simple process that can be performed using just a few basic tools and materials. In fact, many use this process to produce small objects. It's simple, and in terms of equipment, tooling, and molds, it is a low-cost way to produce small objects, making it a popular choice among individuals and manufacturers. Polymer casting is also capable of producing objects in complex shapes. The shape of the casting is dependent upon the shape of the mold cavity. By using the right type of mold cavity, a manufacturing company or an individual can create a casting in their desired shape. On the other hand, there are disadvantages in using casting as a process. For starters, polymer casting is a poor choice for manufacturing companies looking to mass produce a large quantity of objects or product, for the reason that the output rate is slow and has long cycle times. The synthetic resin used in casting process is highly aggressive when exposed to a curing agent. As a result, Molds typically only last for 50 to 100 uses, after which the mold must be discarded and replaced with a new mold. Moreover, moisture and air bubbles can be difficult to manage and may cause problems, which then leads us to not very good dimensional tolerances. Lastly, there are health concerns regarding the use of synthetic resin in the process. During the curing stage, synthetic resins may release toxic and harmful fumes. All types of polymers may be cast, whether it be thermoplastic or thermosetting. Elastomers and composite materials are also included. Most commonly used materials for casting includes acrylics, phenolics, polyesters, and epoxies.
So here are the list of applications in polymer casting. So the first application is transport, automobile, aerospace, railways, and shippings. The second application is heavy equipment, construction, and mining. So the third application is machine tools, machining, casting, forging, extrusion, and forming. The fourth application is defense, vehicles, artillery, and munitions. So here is the fifth application, which is the electrical equipment, machines, motors. And the last application is art objects, sculptures, furniture, and decorative items. So this slide is for the things to consider when casting. First is the type of material. Each material and casting material retains specific characteristics, which is the hardness, melting point, density, etc. that will affect the casting process. The second is cooling rate. This factor depends largely on the type of material from which you craft the mold. Proper cooling is necessary to minimize gas porosity and other negative properties that can result from a fast cooling rate. And lastly, shrinkage. As casting cool, they shrink. To ensure proper component size and integrity, you can utilize risers to feed additional molten metal into the cavity. An oversized mold may be also useful in some applications.
Here we have the frequently asked questions. First is, what is the difference of casting to injection and compression molding? Injection and compression molding rely on significant force to fill a mold, such as injecting and compressing the melted material to create finished products. Casting, on the other hand, relies on atmospheric pressure to pour the melted material into the mold. Second is, how to avoid presence of bubbles from casted parts. One way to remove the bubbles from the melted plastic or solution is by degassing. To do this, the container with the solution is placed in a vacuum to let all the trapped air escape from it. Third, why is polymer casting not an ideal choice for mass production? Polymer casting is not ideal for producing large quantities of products because its output rate is low and it has long cycle times. Next is, what are the two main types of polymers used in casting process? Polymers that can be used in the process are thermoplastic and thermosetting. And lastly, how to choose suitable mold for casting. The following factors must be considered for choosing a mold before casting, and these are the application of the casted part, appearance or texture, and quality standards. That would be all for our presentation. Thank you for listening.